Coming up in this Brightline construction update, this update provides a look at the thermite welding process while a welding crew was working on the Cocoa Yard Lead North turnout. Cocoa Yard Lead North is located in Cocoa, Florida, near West Highlands Drive, and is the northern end of the new cocoa-rockledge siding, which provides access to Cocoa Yard. Two separate welding crews were working together on welds the afternoon I filmed. I did talk with the crews and get their permission to film the process, since I was going to be flying a lot closer than I normally would, and zoomed in. Briefly put, thermite welding is a process in which iron is melted and poured into a form to permanently attach two pieces of rail together. This is done using a self-contained exothermic reaction between iron oxide and aluminum powder, which according to the welders is the hottest man-made reaction outside of nuclear reactions and can heat up to over 4,000 degrees Fahrenheit. It is primarily used for welding the different components that make up turnouts and other special track components, although it can be used in regular track to weld joints. Before I started filming this particular weld, they had placed a hardened sand mold around the joint where the weld would occur. Here, they are preheating the rail ends to get them red hot so the molten iron is not chilled when poured, which could cause the weld to fail. With the rail ends preheated, the torch was removed and a crucible containing the thermite mixture was placed above the mold and ignited. Once it reaches a certain temperature, a plug in the bottom of the crucible melts and allows the molten iron to flow down and fill the mold. Excess iron and slag overflow into a trough to be disposed of, which you can see happening here. Once everything had flowed out of the crucible, it was taken off to the side of the right-of-way to cool down and be disposed of. While it was cooling, one of the crew members began knocking the mold off of another weld done earlier. The little A-frames over the rail on each side of the welds are small jacks that are used to lift the rail so the molds can fit under the rail. Here they are placing a grinder onto the earlier weld to get rid of any unnecessary slag and to get the joint to meet the specified requirements for the rail profile and gauge. Behind the guy grinding They are taking off a metal form that was around the mold that ensured it kept its shape while the weld was being done. The goal of the grinding is to essentially match the shape of the rails on both sides of the weld without any bumps or dips. It also should knock off any of the remaining slag still on the side of the rail. Since the mold is just sand, they were able to just snap it apart and place it on the edge of the right-of-way to cool. You can see it's still glowing orange. They then placed a shear around the remaining mold and cooling metal to cut it down to a rough profile that the grinder could take over from. With it now sheared, it will be easy to knock off once it has cooled further and reveal a rough railhead shape. Throughout all of this, the grinding has continued. Grinding is the most time-consuming part of the overall welding process and needs to be completed before trains can run across it. With only grinding remaining for the day, one of the welding trucks started to leave the worksite. Two FEC track inspectors came to look at the welds to make sure there weren't any glaring problems before trains ran across them. A third-party inspector would arrive at some other point to give it a final seal of approval for both the integrity of the weld as well as the grinding. Thanks again to the welding crew for letting me document the process. Thanks for watching. Be sure to hit the like button and subscribe. Also check out my social media pages.